Alright, hello everyone. This is going to be the first AP Physics 1 video, and today's topic is going to be motion. Alright, so motion is a really common theme in physics, and it basically guides every single thing we do, because if you think about it, when we discuss the movement of objects and how exactly objects work and things like that, motion always becomes a factor. When things are in motion, physics principles apply to them, and we're going to be talking about that a lot throughout the course. So today's video is just going to be an introduction to motion and some types of motion and how we look at motion in physics. So to basically define what motion is, we don't really have a good definition for it, but motion is basically achieved when an object moves. And that might not be a satisfying definition, but that is the matter of the fact because motion only happens when an object moves. And if objects are still, there isn't motion. There's internal motion, if we talk about particles, but motion in general is only achieved when an object moves, and that's the best we can do. So to really dive deep into what motion is, we're just going to be talking about the four types of motion. So there are four types of motion that we're going to be talking about in this course, and I'll be listing them from beginner to advanced, and most likely, not most likely, but um, each type of motion will kind of build off of what we learned in the previous one, all right? So just to get into it, the first type of motion we'll be talking about is straight line motion. The next we're going to be talking about is projectile motion. And this video is just supposed to be an overview. We're not really going to be talking about it that much in depth, but each of these will get its own dedicated section of the course. So the third type of motion is going to be circular motion. And the last type, or the fourth type of motion, is going to be rotational motion. Rotational motion. All right, so to really get an overview of what each of these motions is, I'm just going to be drawing a simple car really quick from above. So this is going to be how you would probably see a simplified car if you look at it from the top. So we have four wheels. Just to make it clear, I'm going to label it car. That's the front. So I'm just going to select this really quick. All right, so let's talk about cars when they're in motion. So for straight line motion, it's pretty simple, but let's talk about a road. So let's draw a road really quick. A road, we're going to draw the lines in the middle and everything. All right, so this is a road. And let's say there is a car that is on this road. So when a car is driving on this road, and we're going to assume that this road is straight, all right? So this road is entirely straight, there's no curves. So when this car is driving on a straight road, the path that it follows looks like this. So this car is going to be following the path of this arrow, right? And to be completely honest, straight line motion really describes itself. It's really just when an object is going in a straight line. But to be more technical, that straight line, we like to call it a linear path. So it's when an object travels in a linear path. And if you look at the word linear, it has the word line in it. That's a way you can remember when an object is traveling in a straight line, it follows a linear path. So just think about when a car is traveling on a straight road. All right, so the next type of motion we're going to be talking about is projectile. So to do that, let's think about a pitcher throwing a baseball or something like that, right? So we have a baseball right there. So when we throw a baseball up into the air, it'll start to go up, it'll reach its top, and then it'll start coming back down. So this is really the path what happens when an object is being thrown in the air and it comes back down. And this path, this curved type of path that it follows, is called a parabolic path. Parabolic path. So if you're familiar with Algebra 1, which you should be because this is an algebra-based course, if we're talking about a parabola, we know that's the shape that a quadratic function makes. So if we know what a quadratic function, kind of like, just to put it out to the side, y equals x squared, This is kind of y equals negative x squared, this path that you're going to be looking at over here, and the path we're going to be talking about for most of physics will be a negative x squared type of graph. And the shape that this makes is what we like to call a parabola, right? So, however, just an object following a parabolic path does not make a projectile. The most important characteristic of projectile motion is that the object, whatever it may be, is only acted on by gravity. So there can be no other forces acting on this object besides gravity. If there are no other forces acting on it besides gravity, then it becomes projectile motion. If you're not entirely sure what I mean by gravity or forces acting on by gravity, don't worry. This will be one of the topics we'll be spending a lot of time on throughout later in this course. This is just meant to be an overview, but if you're not really sure what I mean, don't worry. We'll be making you really familiar with it. But all you need to know is that an object follows projectile motion when it travels in a parabolic path and is only acted on by gravity. All right, so the next thing we're going to be talking about is circular motion. So for circular motion, let's imagine a racetrack, like a car, like a racetrack cars go on. All right, and let's make this a road. So this is going to be the lines of the road. All right, so let's imagine that a car is at the bottom of this path. So when a car travels on a circular or in a race car, the path that it follows looks a little something like this. So it's going to be going around the track. And just like straight line motion, circular motion is pretty self-explanatory. It's basically when a object follows a circular path. So if we think about this car traveling around this path, this racetrack, this is a racetrack shaped like a circle, and when this car travels around that racetrack, it's going to be traveling in a circle, in a circular path. So at its core, that's what circular motion is. The last thing we're going to be talking about is rotational motion, well, the last type of motion, and that's a little bit more difficult to understand, but an easy way to understand is if we think about a top. So let's draw a top. So a top is essentially something that you can use your fingers and it'll start spinning, right? So you let it go and it'll start spinning on a table. It has a sharp bottom, right? So when we let go of a top or let it spin, it rotates like this. It'll rotate about itself. So if we think about this maybe as a line, this top is going to rotate about that line. So one of the main parts of rotational motion that makes it different than straight line, projectile, and circular motion is that this object does not have a path, but it just rotates about itself. It rotates about itself. So we can have a top that's not physically moving, right? So if we look at this car is physically in a straight line motion. It's physically traveling in a straight line. This baseball is physically traveling on this parabolic path, and this car is physically traveling in the circular path. But rotational motion, this top does not really have to be physically moving at all. It can stay in the exact same spot, but it follows rotational motion if the object itself is rotating, right? The object itself is rotating about an axis in that object. An easier example maybe to understand is if we draw a wheel on a car. Let's imagine this is a zoomed in version of a car, and we're only focusing on the wheel. So this is how we draw a wheel, right? So when we look at a car, this wheel is going to be rotating forward. It's going to be rotating like that. So it'll be spinning. It's spinning about the center of the wheel. So this wheel is rotating, right? It's not going to be physically moving in a circle. All it is it's going to be rotating. Obviously, when this wheel rotates, it'll also follow straight line motion as it moves. But if we just look at the motion of this wheel, it's just rotating about the center. So that was just an overview of each of these, just to test if you've learned. We're just gonna do a simple example where might trick you a little bit, but we'll just talk about it. So let's think about a ramp. So we have a ramp, and then we have a ball on the ramp. That's a pretty deformed ball. Let's have a ball on a ramp, right? So this ball is traveling down the ramp. So these lines just are to show that this ball is traveling down the ramp. So just to reiterate it once again, ball rolls down ramp. All right, so this is going to be an exercise. So I'm going to give you the question and you're going to pause the video and you're going to figure it out and unpause the video and I'll give you the answer. So my question is, this ball specifically rolling down the ramp, which of these four motions, straight line, projectile, circular, or rotational, is it following? Keep in mind it may be more than one of these, but the question is which of those four types of motion is this ball following, right? So pause the video. When you unpause it, I'll explain the answer. So I'm assuming you paused the video and we're going to talk about it. So you see that this ball is, so that we see that this ramp is straight, right? I drew it with a straight line. So when this ball is physically moving down the ramp, you can see that it's traveling in a path that looks like this. And this is a straight line. This path is a straight line path. As the ball is rolling down the ramp, it is following a straight line path. So that is one of the motion. It's going to be straight line motion. So this may be one of the ones you thought about because it's pretty clear that this ball, when it's rolling down the ramp, it's physically traveling in a straight line. But the key is that this ball is rolling down the ramp, that this ball is not sliding down the ramp. So when something rolls, not only will it have to move straight, but it also has to rotate, right? It also has to rotate about its center. So this ball is not only just traveling straight down the path or straight down the ramp, it has to rotate about itself to actually roll down the ramp. So this ball is also following rotational motion. Rotational motion. And I specifically chose the example of a ball traveling around a ramp because this is one of the most common scenarios you will see in physics. This idea of a ball traveling around the ramp, traveling down the ramp, is something for some reason that physics professors and people like that love. They love when ball travels down ramp. And they'll try to make the ramp bigger in size, shorter, make the angle steeper. No matter what, you will always see a ball traveling down a ramp. So I wanted to, get you guys familiar with this just to keep it in the back of your mind. So it's important to remember that a ball traveling down the ramp follows straight line motion and rotational motion. Early on in physics, though, because I told you the order of the types of motion we'll discuss is straight line, then projectile, then circular, then rotational. We kind of view straight line and projectile as the first half of the course, and circular and rotational as the second half of the course. So when we first talk about balls or objects going down ramps, we will not really talk about the rotational aspect of it. We'll really focus on the straight line motion because straight line motion is something that's pretty beginner. Straight line motion is a lot easier to understand than rotational motion. And when we talk about straight line motion, the mathematics is fairly simple, but if we talk about an object having straight line and rotational motion, it becomes a little bit more complex. So at the beginning of the course, when we talk about ramps and objects going down ramps, we'll be mainly focusing on the straight line motion aspect of it.